Welcome back to An Electric Revolution. I'm your host, Henry Sanderson. My guest today is Brandon Owens. He's the author of the fantastic book, The Wind Power Story, which charts the rise of wind power from its earliest days. The advent of electricity in America was uneven. While many households in the cities were hooked up to the grid in the first decades of the 20th century, it was a different story in the countryside, on the ranches and farms across America's vast hinterlands. By 1930, fewer than 1 in 10 US farmers had electricity. One solution was to use small wind turbines. Starting in the 1920s, these small turbines spread rapidly throughout the countryside in the US. One of the leading companies was the Jacobs Wind Electricity Company, led by Marcellus Jacobs and his older brother Joe. The brothers grew up on a remote ranch in Montana. They created the first wind turbine by using a fan from a water-pumping windmill and the rear axle from a Ford Model T. The company delivered 30,000 three-blade wind turbines in the US between 1927 and 1957 to farms and ranches across America. Their wind turbines were known for their quality, their sturdiness and reliability. They were called the Cadillac of the trade. One was even installed at the South Pole in 1933 and was still going 2 decades later in 1955. Owens tells me about the remarkable history of the company and how wind power eventually lost out to the central electricity grid. The creation of the Rural Electrification Administration in the late 1930s led to the demise of these small wind turbines as power lines spread throughout rural America. Well, Brandon, thanks so much for joining me.
You're welcome. It's a pleasure to be here.
Well, today we'd like to talk about the Jacobs brothers, which is a fascinating story of one of the most successful early wind turbines from 1930s to 1950s. I wondered if you could just begin by telling us the early life of the Jacobs brothers and where they grew up.
Absolutely. So, yeah, it's a really fascinating story. And, their journey on wind power sort of began out of necessity. And it began before the 1930s. The family relocated a ranch near Vida, Montana in 1910. And like many rural families at the time, they had no access to centralized electricity. So their first solution was a gas-powered generator. But the fuel at that time was expensive and hard to obtain. And so they were looking for alternatives. And that led them to experiment with wind power. And so by the 20s, they had outgrown the power capacity of their diesel generator, and they started developing wind turbines on their ranch. And what they did basically is take the American windmill, which is the common windmill you see on farms, and used a rear axle of a Ford Model T, and it fixed it to DC generator and locked the differential with a pin and created the first wind turbine. And that's how they got into the wind business. And then they continued to experiment. They figured out that it had too many blades, which is sort of a common thing. The multi-bladed American windmill has lots of blades, and that's very good for torque, but it's not real good for velocity. So they kept experimenting. And by 1926, they had figured out that you wanted aircraft-style propellers on the wind turbine, and they settled on a 2-bladed airfoil design. And by 1927, they came up with the 3-bladed design, which is the most common today. It's the industry standard.
And he'd been taking flying lessons, right? That's how he came up with the idea.
Yes, that's right. They were also into flying. And so, they're just experimenting on their ranch to meet their own electricity needs. And they were it was Joe and Marcellus, they were brothers, very mechanically minded. And that's how they came up with their wind turbines. So it's a really interesting story.
And how did they get into business? Was it a case the neighbors wanted one, other farmers, other ranchers wanted one, and then they decided to go into manufacturing?
Yeah, there was local demand, if you will, and they built a very good wind turbine. And by 1931, they actually had sold the ranch and moved to Minneapolis, I believe it was. And when they were in Minneapolis, they opened a wind turbine manufacturing facility. And that's where they really ramped up production. They continued to innovate. I think they were awarded something like 25 patents. They redesigned their generator. Again, they added innovations, and that's when the Jacobs Wind Electric Company was born. And that's when they really started manufacturing in their own right and became a pretty dominant force in the early wind power industry.
Do we know how many they sold? Because I think later in life, Marcellus said he sold about $50 million worth of these turbines.
Yeah, that's right. 50 million over 25 years. I don't have the exact number. They employed 260 workers, and they were at one point producing 8 to 10 wind turbines per day. And there was a massive demand in rural America at the time because they hadn't extended the transmission lines to most of the western U.S. and they were supplying most of farm country with Jacobs wind turbines.
And then they were known as the Cadillac of wind turbines. I mean, they were incredibly reliable, right, and incredibly good quality.
Yeah, I mean, in some sense, they were overbuilt. They were expensive in their day. You could get a less expensive, less reliable machines that were in the market, but they had a lot of pride in what they did, and they innovated. And so they were very successful. And there's even a story about one of their wind turbines being installed at the Byrd Antarctic Expedition Base in 1933. And that turbine, legend has it, actually operated for over 2 decades in some of the harshest conditions on Earth. And that really kind of proved the durability of their wind turbines.
Yeah, I think his son went back right to the site and saw that it was still going.
Still running. Yeah, that's an amazing story.
And the other interesting thing you do in your book is you calculate potentially the cost of electricity from these turbines, which you say was, I think it was around 21 cents a kilowatt hour, which you say was cost competitive to electricity from utilities at the turn of the 20th century. But by 1930s, that cost had come down quite considerably, right? So they couldn't really compete.
Yeah, I mean, that's the story of wind power throughout the 20th century. Just always chasing this moving target. 20 cents a kilowatt hour, that's not bad, actually, even today. But when you're able to get power from the grid at 10 cents a kilowatt hour, that just doesn't work. And so it was always sort of chasing the moving target. And what happened with the remote wind power installations, putting in the 1930s, of course, you had the Rural Electrification Act as part of the New Deal. And that led to the expansion of the transmission system in rural America. And that really was kind of the beginning of the end of remote grid and small wind turbines in the U.S. Now, it took a couple of decades to play out, but as they expanded the grid, one of the preconditions to hook up some of those remote locations, some of those farms, is they actually had to take down some of the existing wind turbines that they had. So they had to remove the existing generators before the utility would come out and actually install the transmission network. So that was the death knell, the slow death knell for these remote systems and for wind power in global America.
Was there no pushback, given that they had a successful business and there were other companies, right? Was there no lobbying or pushback against that build out?
There was pushback, but there wasn't much you can do. I mean, the had been passed. It was part of the New Deal. I mean, you've got sort of powerful utility and government interests who pass this legislation. And look, I mean, rural electrification was seen as a good thing. I mean, people wanted the electricity. They wanted to be able to use the appliances, the radios. And so it was sort of a slow motion death for these small DC systems.
So the farmers were happy to give them up then?
They were, yeah, ultimately, yes.
And then later in life, when there was, in the 1970s, I guess, a wind power revival, it seems from reading that Marcellus Jacobs wasn't actually that supportive of the industry, and he's kind of a bit of an old curmudgeon. Why do you think that was?
Well, actually, there's something interesting that happened in the 1950s, which was a slow period for wind power, at least in the United States. There was some research and development happening in Europe at the time, and there was an effort to conduct R&D in the United States. And there was a bill that was passing through the U.S. Congress. And there was an effort to garner support for that legislation, which would have led to the development of wind research and wind turbines as a complement to hydropower, which is actually a pretty good match. And Joe Jacobs actually wrote a letter to that congressional committee against that research, indicating that large wind projects would be a failure, and indicating he had an insistence that only small wind turbines were the only viable solution. And that really left a bad impression on what was the wind industry at that time, and helped lead to what was really a stagnation in wind energy development for the next couple of decades. And so I think the Jacobs brothers, Marcellus and Joe, I think from the beginning believed that, small wind turbines, these were DC, not grid connected systems, that was the appropriate role for wind power. And so then you fast forward to the 1970s, and what's happening in the 1970s, of course, is you have the oil crisis, 1973 oil crisis. And then the reaction to that was, well, in the U.S. and in Europe, we need to ramp up all of these research projects. In the U.S., that was done through NASA and later DOE, a lot of fund for large-scale wind turbines. And these are wind turbines of megawatt scale. And of course, we're in of megawatts now, that would be grid connected. So these aren't DC remote systems, they're AC grid connected systems. And so the idea, we were going to conduct research and build utility scale wind turbines. And so that's what the whole thrust of the activity was in the 70s. And that was the beginning of the American Wind Energy Association and those lobbying groups and all of that government R&D. And so now this is the long answer to your question. And so those groups at the time were reaching out to Joe Marcellus, because he was a legend in the industry and, the most successful wind manufacturer in the U.S., to kind of pull them into their efforts. I think they wanted him to accept and sort of bless what they were doing. He sort of had the same attitude that he had the whole time, which was that these are small DC systems, and we've sort of already figured it out, and there's no reason to try to build these large multi-megawatt systems that you want to interconnect into the utility system. And so there was this tension there between kind of the other wind manufacturers and sort of at the time, kind of this newer school innovators in the wind industry.
Well, was he right in some senses? Because what I read is that the government R&D programs failed, and the sort of attempt to go big straight away didn't succeed, right? And actually Denmark took a sort of, go slow approach. Is that right?
Well, you took the words right out of my mouth. He, in fact, was correct. The way that we ultimately reached megawatt scale was through incrementally increasing the size of these smaller wind turbines, and then gradually interconnecting them to the grid and gradually developing that technology. But you always started with these robust farm-based systems. In fact, what became Vestas, that technology was very similar to the Jacobs technology. And if you look at the Vestas pathway, the Denmark manufacturer, and they started with this very small, I think it was 100 kilowatt system. And, and it's 110, 120. And it's through the 80s, they gradually upsized with the technology. And so I think if in the 70s, if the initial approach had been, let's take the Jacobs machine and figure out how to increase its size by 15% and go from there, I think Joe Jacobs would have been on board with that. And I think that would have actually led to a lot more success in the U.S. R&D program.
That's fascinating, because that's kind of a lesson I guess the West is facing today when we think about competing with China. Do we sort of like go big and build the biggest things we can, or kind of incremental improvement? So maybe there's something from history we can learn, right?
Yeah, I mean, we've got these large offshore wind turbines now. I mean, we're in the tens of megawatts now. The question is, so kind of where do you go from here? Can they get any bigger? So it'll be interesting to see how that industry evolves from here.
So just to compare, I mean, you said today we're at tens of megawatts. So the original Jacobs turbines were sort of 2-3 kilowatts, right? What could they actually power on a ranch? What could they actually do?
Oh, I mean, you're doing lights, radios, things like that. Initially, small motors. And then, you're working your way up to small farm equipment, things like that. I mean, the power needs were pretty modest at that time as well.
You couldn't do a television, right? I guess that was one of the...
Yeah, I think probably it wasn't until the 50s that even that was a need.
And do you think, looking back, that there was possibility for, a decentralized system that could have incorporated some of these elements?
Well, I mean, that goes back earlier than the 30s or the 50s. That goes back to the 1890s, when the power system was first developing, and you had Pearl Street Station, which was the first power plant in the U.S., and then run a DC system, which had to be more local because it was lower voltage, and you had to eventually transfer over to AC, high voltage, to go a longer distance. There was this brief window where, look, you could either do kind of these small localized systems with distributed resources, or you could switch over to a larger AC network and then kind of upscale everything, including the machines, and then you could, use larger steam turbines. And we ended up opting for the latter, and the whole system upscaled, and we went with this centralized hub and spoke model. And there was an argument to be made at that point that you could have gone the distributed path, and in that path, wind turbine would have been a major player. And so we sort of got locked into the centralized hub and spoke model. So that decision was made much earlier. The distributed model could have possibly worked. Wind power was at a point where it could have played a role. Denmark did a little bit of that hybrid. They have much more of a decentralized system. But as I said, we kind of got locked into that centralized system, and that decision was made earlier on. And that's what locked wind out by 1910. And wind had been on the sidelines ever since. And the only role that wind was going to possibly play was in the non-grid connected market. And that's the role that wind power played in the 1910s, 20s, and 30s. And then right around the time that Jacobs was starting to hit its stride in manufacturing, and wind was really doing well in the non-grid connected market, the REA comes out, and they start electrifying and expanding the grid, and then that market collapses. And then that's why you have basically wind is nowhere to be found in the 30s, 40s, 50s, 60s. And then in the 1970s, you have the energy crisis, and wind is rediscovered, right? And they say, oh, wind is important. Let's go build big wind turbines. And then you have all the drama around that. So it's a really interesting history about wind power, where it was and how we got to where we are now. And Jacobs played a real central role in not only the technology innovation, but all of the drama surrounding that big wind, little little wind sort of dichotomy.
And he did inspire a lot of people in the 70s who actually went around and repaired some of these machines, right? I actually chatted to Paul Gipe in another episode. Yeah, repaired these machines and made them still work, right?
Yeah. He was a legend, and a lot of folks believed, rightly so, that sort of small wind, off-grid applications where wind really hit its stride, and that those machines worked really well, really reliable, and were really important. And there were a lot of sort of refurbishing. And as you said, the past was the future. So in the 1970s, folks who were focused on those Jacobs wind turbines, that technology is basically the bedrock of the technology that we have today, because it was the incremental upscaling of that technology that is going to lead to the multi-megawatt machines that you see installed across not just the United States, but across the world today.
So quite a technical innovation then from the brothers in terms of going for that 3-blade design, right? And choosing that route.
Yeah. They played a big role in the evolution of wind power.
Well, Brandon, thanks so much for joining me today. It's fascinating to hear your thoughts, and I do recommend everyone read your book, The Wind Power Story, which is a fascinating account of winds from the origins to the present day. So thanks for joining me.
Thank you so much. Pleasure to be here.
Thank you for listening to An Electric Revolution. Don't forget to hit subscribe to get all future episodes. You can also follow my newsletter on Substack. It's called Volt Rush. That's voltrush.substack.com. Thank you very much.